Hello, chemistry fans. This is Lab 29 for Honors Chemistry, Disturbing Equilibrium. In this lab, you will be doing 3 different reactions, all very quick, but each with something to show you about equilibrium and what it is and how we can adjust it or cause it to be disturbed and then see it restored. So a few little things before we get started. Under materials, you are also going to need a test tube rack. Of course, you will find that in the drawers at the end of your lab benches. You will need a 50 milliliter beaker, which I will have out for you. Make sure you get one of those before you get started. And you should also know that the concentrated HCl that's listed right here is not found directly in those little red dropper bottle racks that are on the tables on the lab benches next to you. I will come around and dispense that. Otherwise, these other solutions, the potassium chromate, the H2SO4, sulfuric acid, the sodium hydroxide, which is the base, the iron nitrate, and the potassium thiocyanate are all in the little red racks in dropper bottles right at your lab stations. So to get started, in part A, you will be placing, it says 2 fingers widths of saturated salt into a clean test tube. This is a very technical measurement of volume, 2 fingers width. I don't know, maybe a quarter of the test tube full. This is not precise. This lab is not a quantitative one. It is a qualitative one. So you don't need to be exact. You need to be able to see what's going on in the test tube. Please put that saturated salt solution in here. You are going to need my help at this point. I'm going to come around with the concentrated hydrochloric acid. When I get to you, I will add it to the test tube, and you can make your observations at that point, and you can move on to part B. So if I don't get to you right away, then once you have poured the salt solution, go ahead and move on to part B. When you are done with part A, you can dump the products in the drain. There's no special disposal for part A. In part B, the chromate dichromate equilibrium. As I mentioned earlier, you have 2 substances here. You have an acid in the form of H2SO4. You have a base in the form of sodium hydroxide, and you're going to be using each of those one at a time and adding it to a test tube that contains potassium chromate. In this test tube, it says to place about a finger's width. So notice this isn't 2 fingers, it is 1. You need less than you need it up here. The primary reason for that is because when you are done, the disposal for this, you must put in the hood. You do not dump part B down the drain. This needs special care because of the chromate ion. It's particularly toxic, and you will need my help in disposing of that. So please do not put part B's results down the drain. Now, when you add the acid to the potassium chromate in a test tube, it says record your results. The results, whether it's part A or B or C in this lab, are down here in the data section. So first you will record your observations, whatever happens when you add, this is part A, when you add the extra concentrated hydrochloric acid. In part B, after you add the acid, so after you add the H2SO4, what happens? What do you see going on in that test tube? It may be in the color change or solid production. Whatever you see, that's what you're going to record there. Now I know it's early in the unit for this lab, but what I would like you to try to do is to notice that this table right underneath your initial observations, you did this right here. You added acid. So you're not going to write anything in there. But what you're going to do is, based on your observations, you're going to decide what happened to the amount of this chromate ion or this dichromate or water. And so depending on what you see happening in the test tube, if it becomes more yellow, well then there would be more of this. If it becomes more orange, well then there wouldn't be more of this. There would in fact be more of this. So you can indicate with arrows here and here. At this point, do not fill in this box. You can maybe take a guess if you want to try to do that in pencil. I promise you might want to change your answer later. But having viewed that video, that music equilibrium video that I wanted you to start with, maybe you can take a shot at this. We're going to talk about this more in the days surrounding this lab. If you want to take a shot at it, go ahead. All right, so part B, once that's done, you can move on to part C. It's very similar to part B. You're just going to be using a different chemical to create an equilibrium. This is the thiocyanate equilibrium. So you're going to start by adding 5 drops of the iron nitrate and 2 drops of potassium thiocyanate, and that's where you're going to need your 50 milliliter beaker. As far as this 40 milliliters of distilled tap water goes, you can use your little 50 milliliter beaker and you can just approximate. So you'll have little drops of the iron nitrate and the thiocyanate in the beaker. Go ahead and add water up to the 40 milliliter mark. It does not have to be exact. Remember, this is not a quantitative lab, it's a qualitative lab. So that will be precise enough for our work today. Go ahead and do as the remainder of the procedure in Part C asks, adding to 3 different test tubes the required solutions. Again, record your observations down below here in Part C. Add the iron, what happens? Add the thiocyanate, what happens? And then see what you can do with this table. We will certainly talk about it together in class. When you're done with Part C, the chemicals for this part may in fact be dumped down the drain with lots of water, as the instructions suggest. So it's only part B that you have to worry about special disposal for. Okay, that's it for equilibrium in the lab. Good luck!